Okay, so hey guys, we're going to go ahead and go over day 5 notes today, molecule polarity. But before we do that, let's go ahead and just review a little bit about bond polarity, what we learned yesterday. Okay, so with bond polarity, in covalent bonds, shared pairs of electrons are pulled between the nuclei of atoms that are sharing them. Okay, sometimes electrons are pulled equally and sometimes they are not. Okay, so those two types of bonds, those two types of covalent bonds are nonpolar and polar. So your nonpolar bonds are the ones that are pulled equally. They have the same electronegativity, or based off what we learned yesterday, they have a very low difference or small difference in their electronegativity, and it gives them a nonpolar bond. Okay, now if they are not shared equally, then they are considered polar bonds. Okay, that means that they have a really high difference in their electronegativities. So one element is going to have a stronger pull on the electrons than the other one is. Okay, so for molecule polarity, we're going to be looking at the whole molecule. Okay, instead of just looking at bonds, we're going to take a look at the whole molecule. So if a molecule has all nonpolar bonds, then the molecule is going to be nonpolar. Okay, and if a molecule has a polar bond, then the whole molecule is usually polar, but not always. Okay, so there's a number of things that that'll help us determine this with more certainty than just doing it this way. So, okay, that criteria would be these 3 rules right here. Okay, and I'm going to be honest with y'all. For molecule polarity, this is really what you need to know right here. These 3 rules, okay? So to determine if a molecule is polar or nonpolar, then you are going to look at the central atom. Okay, so just like our molecular geometry, we always look at our central atom to determine its shape. Well, we're also going to use the central atom to determine its molecule polarity as well. So for number 1, if the central atom has no lone pairs and has all of the same type of atoms attached to it, then the molecule is nonpolar. Okay, so again, if it has no lone pairs and it has all of the same types of atoms attached to it, then it's going to be nonpolar. Okay, so rule number 2, if your central atom has no lone pairs, but the atoms attached to it are different, then the molecule is going to be polar. Okay, so the only difference between rule number 1 and rule number 2 is the atoms attached to it. So if they're the same type of atoms, then it's going to be nonpolar. Okay, but if it's different atoms, then it's going to be polar. Okay, and then third and last, if the central atom has lone pairs, then your molecule is polar. What we like to say for rule number 3 is lone pairs equals polar bears. Okay, so lone pairs equals polar bears. Okay, so if you have any lone pairs, then your molecule is going to be polar. Okay, so in other words, if the molecular geometry is symmetrical, the bond polarities cancel and the molecule is nonpolar. Okay, so let's go ahead and take a look at some molecular geometry so we can see what it's talking about. Okay, so if you guys remember, on your molecular geometry chart, these are the first 3 shapes. We have linear, trigonal planar, and tetrahedral. Okay, so what you should also notice about these is that they do not have any lone pairs. Okay, their central atom has no lone pairs. So these can all be considered symmetrical shapes, okay? But you do have to be careful because sometimes they might not be the same elements. Like all these silver circles or silver dots right here, these could all be different atoms. So remember, if you have different atoms attached to your central atom, then it could also still be polar. Okay, so be careful with that. They are usually symmetrical, but then it all depends on what your elements are that are attached to your central atom. Okay, so our first example, we have carbon dioxide. Okay, so I'm going to go ahead and give you a second to go ahead and draw your Lewis structure for carbon dioxide. Okay, so based off those three rules, remember we are looking at what's attached to our central atom and do we have any lone pairs attached to carbon. So are the atoms attached to oxygen the same or are they different? Well, we have two oxygens, so that means they are all the same. Okay, and do we have any lone pairs? Well, carbon does not have any lone pairs. So based off those two criteria, this would be considered a non-polar molecule. Okay, but remember we also have other criteria that we can use, but that explanation would be the simplest. Okay, we have two of the same atoms and we have no lone pairs. But another way we can look at it is our bond polarity. So we have two polar bonds. Okay, because we have two polar bonds, our bonds are actually going to cancel each other out. Okay, so our bonds are going to cancel, and then remember the first three shapes of our molecular geometry chart, linear, tetrahedral, and trigonal planar, well, this is linear. So because it's linear, it is symmetrical. Okay, so again, all those criterias all point to having a non-polar molecule. Okay, but again, if you would just prefer using those three rules and just looking at do you have the same atom and do you have any lone pairs, then that's all you really need to know. Okay, so let's go ahead and take a look at our next example. Okay, just a little illustration of our carbon dioxide molecule, okay, because we have two polar bonds, they are going to cancel each other out. They're basically the same strength, and so our little penguin here is just holding on for its dear life. It is a non-polar molecule. Okay, again, our bonds are both polar, so they cancel each other out, and because it's a linear molecule and it has no lone pairs, it's considered a non-polar molecule. Okay, so methane. Okay, so remember the two questions you should always ask yourself for molecule polarity. Are the atoms that are attached to your central atom, are they the same or are they different? Okay, and does our central atom have any lone pairs? So we have 4 hydrogens around carbon, so that would initially make it non-polar. Okay, and do we have any lone pairs on our central atom? And that answer is no. So this would make this molecule non-polar. Okay, so just because of those two things, they all have the same element, hydrogen, and they are all, or I'm sorry, carbon does not have any lone pairs. So again, it is a non-polar molecule. Okay, but if we take a look at bond polarity, you'll notice that, hey, we have polar bonds, 4 polar bonds. So because we have all of the same bonds, they are going to cancel each other out. And then again, this is a tetrahedral molecule. Okay, its molecular shape, its molecular geometry is tetrahedral, one of the first three on our molecular geometry chart. So again, it is symmetrical. Okay, so we would have a nonpolar molecule again. Okay, and then lastly, we have water. Okay, so do we have the same elements attached to our central atom, which is oxygen? And we do. We have 2 hydrogens attached to oxygen. So it can mean that we have a nonpolar molecule. But we have lone pairs. So remember our little saying, lone pairs equals polar bears. So that means that because of those lone pairs, because of the Vesper theory, it makes this entire molecule a polar molecule. Okay, all because of those lone pairs. Okay, so water has a bent shape due to its unshared electrons, and because of that it is not symmetrical, and the polarities do not cancel. So that means we have a polar molecule. Okay, and then in a polar molecule, one end has a positive charge and the other has a negative charge. A molecule that has poles is called a dipolar molecule or a dipole. Okay, which we can go back and look at water. So water, again, it has two positive, or rather a positive side and a negative side. So this would be considered a dipole. Okay, now that concludes our notes for today. You guys do have homework on page 13, and because we have so much time left in class, I do want you to go ahead and work on your homework as classwork. Okay, so you have until the end of the period to show the sub that you've completed page 3 for a completion grade today. Okay, and if you have any questions, please don't be afraid to ask. If you need help, please ask. Okay, you guys have a great day.